Hi there, I'm Stefan Kruger from Cloudant. I'm going to walk through a little demo of some basic MapReduce stuff, how to do analytics and some time series analysis and aggregation, and sort of stuff that Cloudant's MapReduce implementation is pretty good at. So let's get started. What I'm going to do, I have a data set. It holds about a decade's worth of air crashes data from the states, from the kind of aviation authorities, where things happened, how many people got injured, what kind of make-up plane it was, and that sort of stuff. And I have this CSV file that contains the data. We can have a look at some typical samples of it. It's basically stuff, locations, got fatalities, and what kind of aircraft it was, etc. So this is actually a kind of work through of an old blog post written by Mike Miller, one of the founders of Cloudant, way back in 2011. So a lot of things have changed since then. So I'm just going to kind of work through the same kind of workflow that like he did in this blog post. So what I'm going to do, I'm going to create a database here. Aviation. I'm assuming that you're familiar with the Cloud dashboard. So basically, empty database, and then what I need to do is get this data file into convert it to JSON and shove those documents to my Cloud database. I'm going to be using two tools. One tool is written by another member of staff here at Cloudant, and that's called Couch Import. It's a Node application. I've already got it installed, but if you want to install it, the way to do that is via npm. Just install -g Couch Import. I'll bore you with that. I'm also going to use this wonderful JSON processing tool called JQ that allows you to pretty print, and actually it allows you to do lots of things. We'll only scratch the surface for what it can do, but that's certainly something that's worth investing some time in learning if you're regularly dealing with JSON. I'm also going to define a couple of command line, a couple of environment variables. I'm going to export something called couch_URL. That's something that Couch Import expects. It's basically your Cloudant account and your username and password. I won't actually do this, but I've already done it. And I'm going to do exactly the same for a shorter one. With the shorter name, just to save my own typing, and that's going to be basically following that format. You'll see why in a minute when I do lots of kind of curls and stuff like that. It gets tedious to type all that out. Right, so the first thing I'm going to do, I'm going to take this CSV file. I'm going to cat that into Couch Import, and I'm going to specify the database, which was called Aviation, I think. And specify the delimiter, which is a pipe symbol for whatever reason. Now this is reasonably fast, but it's a lot of data. We're talking 70,000 lines or so. That needs to wing its way over to my current Cloudant account is hosted in Dallas, I think, and I'm in the UK. So let's start that. It's pretty swift, and it runs kind of, it processes this in blocks of 500s, but by coming to the end now, not that much more to go. It's like watching paint dry. .66, yeah, nearly there. Boom, there we go. Great. So now we should be able to see that in here, hopefully. So yeah, you can see it's got 68,387 documents. View those. The things we care about for this purposes of this little demo. There's a model, a make, which is the manufacturer of the aircraft. We have fatal injuries I'm going to look at. As you can see, these are the things that are actually stored as strings. Could have done a better job when we passed this. And there should be somewhere a date. Where is it? Event date, there you go. So that's the one we're going to be looking at in a minute too. Now we can obviously, in the kind of Cloudant way, we can talk to this database using curl. Curl is a kind of command line web client, HTTP client. It's a very capable tool actually, and very useful for doing kind of quick and dirty kind of accesses to a Cloudant database. So we can try this. So curl -s for just be a bit silent. The URL, which is one of these variables. Aviation _ all docs, which is a listing of all the documents in this database. I want to say include the actual docs payload as well, equals true. And the let's say that we limit ourselves to 5 documents, and I'm going to pipe that through JQ dot. Just get a bit of pretty printing. So basically take the first 5 documents of the database, and you see you get that sort of similar data as we can see over here in the Cloudant dashboard. So that seems to work. That's good. Now, Cloudant is a document database, what you can do without doing anything else is to look up documents based on their ID, or possibly their ID and revision. Now that's all well and good, but I want to be able to find all the documents for a given brand of plane, say Cessna, for example. Yeah, it's really kind of an inverted index, and that's kind of the absolute sweet spot for the kind of MapReduce stuff that Cloudant can do. So we can accomplish this using a map-only view, so no reduce step. And what we need to do is the way that you do this in Cloudant is that you write a little function in JavaScript to do the kind of mapping and emitting into a secondary index. Now you can actually do that using curl, but what you need to do then is encode a JavaScript function into a string, which gets a bit tedious. There are other ways, command line tools that you can do to kind of upload files, but actually for our purposes it should be sufficient to just do it in the Cloudant dashboard. So we can go to this thing here called design documents, and so we want a new view. I'm going to call this, you have to name your design document. So the design document is basically the definition of where you keep the definitions of your view functions. Yeah. And I'm going to call this first one we do, I'm going to call that sort. And these view functions, they tend to follow a similar pattern. And so you do an if statement where you check some kind of conditions on the document to make sure that you're dealing with the right sort of documents. So check that a certain field exists. That's a make, I think it's called. So if the document is there and it has a field called make, I'm going to emit into the secondary index as a key the doc.make. Actually, I'm not going to emit any data because this is an inverted index only, so I'm just going to do null there. So it's basically a key, it's basically a kind of a dictionary that only has a key and it maps to null. So we're not going to put any reduce in because we're only interested in the map. We create that, and after a few seconds that should have been completed. So you can see now the key here is the make, a 107.5 flying corporation. Interesting, but there's no value itself, yeah, it just pulls in the document if you get there. What else do we have in here? AAA, aircraft leasing, etc. Yeah, there's lots of strange manufacturers that I've certainly never heard of. Right. So now we can do a couple of things here. So if you want to see what that design document, the definition of this actually looks like when it comes back, yeah, we can do that by OKL as well. We can say aviation design example 1. So that was the name of the design document. So we can just fetch that as it is without running anything and just see what it comes back at. You can see that we have a set of views. One view, the first view, the only view at the moment is called sort. The map function is defined as some string encoding my JavaScript function, and a specification of the language is JavaScript. Yeah. So let's query this. So let's say that we talked about Cessnas before. So let's try to find some Cessnas. So we want to then call the actual view, and the view was called sort, and I want to say that the key equals Cessna to encode the. Actually, we would probably want to say that we limit ourselves to 10 documents. I'm sure there are more than 10. So we'll try that. So here we get back then the IDs for the document and the keys, the key which is Cessna. So that's actually only moderately useful. So let's tag on the documents themselves, the payload, like, yeah, we should be able to get that, like, not very helpful, pipe jq.docs. No, not docs, rows. So there we go. So basically now we can see that the key is Cessna, and there should be a make in here, which is Cessna. So that's basically, picked out from this huge stash of documents, only the first 10 documents that has a make of Cessna. Now we can use this to, for example, what should you fly? Should you fly an Airbus or a Boeing, for example? Yeah. So we can say, if we go to here and say that we want to try Airbus. So we can do count these by doing something like this. There's a Unix command thing that counts the number of lines. It's not totally accurate in this case for reasons I can explain in a minute. But okay, so Airbus 15. Boeing had an occurrence of 773. Note that this is obviously in the US, so there are plenty more Boeings flying. It's a bit of a shoddy way of doing aggregation, and it's not even exactly correct, because the output, if we just look at the output of the first one there, so you can see it's got some other lines here, so that clearly doesn't. It's not a real data carrying line and those, yeah. So actually, it's probably 2 less than that, yeah. So what can we do in order to get the database to do this aggregation for us? Yeah, that's why we have a database here. So let's look at a way of doing the aggregation properly using MapReduce. So let's go back to our view and the view definition here and edit that. So instead of emitting null, which is the bit that the value is the bit that the reduce step acts on, yeah. So let's emit the number of accidents represented by this document, which is obviously 1. Yeah. And then we can pick a pre-canned reduce function, the sum, which basically just add these values up and kind of run that reindex. So what we should be able to do now is to say, now that we have a reduce, we can do basically just that again. So now we can see that actually what we get back is then the reduce values. So the reduce step kind of combines all the values into a single value, an aggregation, if you like. Yes. Now we have the proper. You can see the proper value there minus the. It doesn't suffer from my hokey WC minus L approach there. Now we can do the same for Boeing. 771. We'll try the Cessnas. Boom! Oh, lots of Cessnas come down. Yeah. So basically, now we have a way of relying on the database to do the aggregation for us. So basically, what's happening here then is that the reduce function goes through what was emitted into the index and just adds up all the values of the rows emitted into the index by the map function. Now, if we run this without a key, we should get the total number of accidents. So if we take the key off here, it should just reduce over the whole data set, so 68,334. Now, perhaps more usefully, we can also use this to group based on the based on the key in this index. So I can say group equals true. We probably want to do more here because there's going to be quite a lot of them. So here we get then basically a list of number of accidents across the data set grouped by the maker plane. Yeah. Now you can see here we have it's actually some interesting data could be better deduped there. So errors, it's a similar thing there. But basically, just group by the key and then reduced onto that. Yeah. So that's reasonably helpful. So let's look at what we can do. So that as I mentioned right at the beginning, is that this data set, these documents also contain a timestamp. Yeah. So let's see what we can do. And doing some basic time series type analysis, sort of aggregating and grouping over time spans and things like that. So for that, what we're going to do is that we're going to make an other view. So add a view here, and this view I'm going to call, what are we going to put it? By date. So we need to do a couple of things. We need to emit, in order to do kind of slices on dates or slices on any kind of data set, we need to emit a vector valued key and a vector valued value as well. So we need to pass the date and then emit a kind of length 2 vector that contains the year and then the month. And then we can do analysis on slices of that. So if doc and doc, now the time field is called something like event, I think. I want to make sure that exists. So if it does exist, I'm going to pass the date field into a JavaScript date object. JavaScript's quite good at that. So we can say something like equals new date parse. And what am I parsing? This field there. And then, so as I also mentioned, I was a bit lazy when I converted the data, so lots of things that should be numbers versus strings. So what we need to do is find the fatality number of fatalities and ensure that that's actually represented as a number. So 0 by default. Then we can say if doc, and the field we're interested in is called total fatal injuries, and if that is not equal to the empty string, what we should do is to say that the fatalities is to convert the string to an integer, pass int that. And then that one there, we can lift, and that needs to go in here. So now this is where we need to try and be a little bit. So we need to emit a vector as the key and a vector as the value. So the key here then is the year and the month. We can tap that out of the JavaScript data object. So we can say then dot get full year, and the month then dot get month. Okay, for the value, we're going to emit as the first item the number of accidents that this document represents, which is 1 as before, and then the number of fatalities that this accident was associated with. So that was the fatalities. Did I type that right? Yeah, looks like it. And then we can still use the sum reducer. So the sum reducer is smart enough to do the right thing. If you emit a list, yeah, it will just sum on a per component basis. And in fact, if you emit an object, JavaScript object, it will do the same. It will sum based on a kind of per key, if you like, if you view the object as a dictionary. Okay, so what remains to do is to build this. Cool. So we can see the 0 represents January 1982. So we have a vector value key 1982 followed by 0. So year, month, and the value. There was one accident and 0 fatalities. Yeah. So, okay. Right. We can now group accidents by year and month and total up the number of fatalities. Yeah. So we can say something like curl minus s and the $URL so by date in the example 1 design document still. So the by date, and what we're going to do is we're going to group at level 2. And what that means is use both parts of this key when we view. Yeah. So here we have it. Yeah. So year, month, total number of accidents and total number of fatalities. Yeah. So let's pick that one at random. December 1983, 210 accidents and 90 fatalities, etc. Yeah. So now we can change that. Yeah, we can sum it per year. Actually, we don't really need that. We can just use the first component, which is the year, and just do the aggregation on a per year basis instead of per year and month. Yeah. So we now then get only the years. Yeah, so we can see that at a glance which is the worst year. We have 3,593 accidents back in 1982. So it seems like it's heading the right way, more or less trend downwards, which is positive, I guess. Or we can do it like over the whole data set, yeah. So if we set group level 0, there's no grouping apart from the whole data set, yeah. So we get back what we had before: 68,387 accidents, 38,652 fatalities. Now the final bit I'd like to show is how to pick out smaller ranges out of this, yeah. So we can, by using something called like start and end key, we can pick out a single year, for example. Yeah? So we can say here, start key equals, let's say we take 1994. As you can see, I'm only giving, even though I'm passing in a key as an array, I'm only giving it the first bit of the key that I'm interested in, which is part of why this is useful. And the end key is then 1995. So what this says is that go through the index and give me all the data that has the first component of the key being 1994, and stop immediately you get to a key that is 1995, non-inclusive, yeah? And group that at the maximum level, which is year and month. So there we have it. Yeah? So a single year picked out, aggregated by year and month, showing the number of accidents in total, plus the number of fatalities. So that was all I was going to show. So again, to recap, Cloudant has some very useful features to build secondary indexes using the MapReduce kind of paradigm. This is a rehash of a very old blog post by Mike Miller. I recommend that you read this. Things look a bit different, because things have moved on since 2011, but there's still some very interesting and useful data in there. So take a read of that. And thanks for listening.